So welcome to the third day of Unit 3 of PreCal for Seniors. So what we're going to do in these set of notes is talk about exact values of these unit circle values using the exact points. So at the end of last notes, we kind of created this table to show you all the angles that are on the unit circle in terms of radians. Well, the two triangles that we're kind of talking about are the 30, 60, 90 triangle and the 45, 45, 90 triangle that have the hypotenuse of 1, which, if we're talking about 30 degrees, has that point root 3 over 2. If we talk about the 60-degree reference, we just flip the x and y coordinate. And then 45, 45, 90 has the root 2 over 2, root 2 over 2. So first, what I want to do is go back to our unit circle, and let's fill out that unit circle in terms of radians. So I kind of took some old notes, and here is my unit circle in terms of degrees. Well, what I want to do is I want to put this in terms of radians. So what I'm going to do is I'm going to do the axes first. So 0, pi over 2, pi, and 3 pi over 2. That was, pretty easy from what we already talked about with introducing radians. Well, 30 degrees is the same thing as pi over 6. And what I'm going to do is I'm going to show you a trick on how to find all the pi over 6s in all the 4 quadrants. So that's the first one. The second quadrant is going to have a numerator that doesn't reduce with 6. So if I change the numerator to 2 pi over 6, that reduces to pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. And then 5 pi over 6 is going to actually be my next angle. That's 30 degrees. And remember, the 30-degree reference angle is always the points that are closest to the horizontal. What about the next number that doesn't reduce with 6? That's 7 pi over 6. And then what's the last number that I can put on the top of a fraction with the denominator 6 that doesn't reduce? 11. So that's how I figure out my pi over 6s. And I could do the same thing with the pi over 4, which is 45 degrees. What's the next number that I can put on top of pi over 4 that's not going to reduce? 3 pi over 4. And then 5 pi over 4. And then lastly, 7 pi over 4. And then for 60 degrees, that's the same thing as pi over 3, which is going to be a lot easier to figure out the next numerator because it's just 2 pi over 3, and then 4 pi over 3, and then 5 pi over 3. So now you have a unit circle that has all of the ordered pairs, all of the angles in degrees, and all of the radians. So you can use this unit circle to answer any of the questions that we have on the next page, or we're going to kind of go through that problem solving that we did back when we did exact values with degrees. So if we're talking about cosine at 0 degrees, well, at 0 degrees, it's the point 1 comma 0. Cosine is the x coordinate of that point, so 1. That's it. Done. That's your answer. But what about 270 degrees? Well, 270 degrees is point 0, negative 1. Cotangent is x over y. Again, it is a reciprocal of tangent, but think about it as x over y. That's 0 over negative 1, which is 0. Done. 5 pi over 4. Well, if it's pi over 4, it has to be root 2 over 2 and root 2 over 2. It has to be that coordinate plane or coordinate point. Now the question is, where is 5 pi over 4? Well, we have 1 pi over 4, 3 pi over 4, 5 pi over 4. That's quadrant 3, so they're both negative. Since we're talking about cosine, that's the x coordinate of that point. So negative root 2 over 2 is your answer. And again, none of this work has to be shown. You could go onto your unit circle that we just filled out, look at 5 pi over 4, and get negative root 2 over 2, and that's it. Done. Cosecant of 180 degrees, the point at 180 degrees is negative 1, 0. Cosecant is the reciprocal of cosine. Well, cosine is negative 1, or sorry, cosecant is the reciprocal of sine, my bad, which is 1 over y, which is the reciprocal of 0, which is the same thing as 1 over 0, which is undefined. Make sure that looks like an F. All right. 3 pi over 2 is the ordered pair 0, negative 1. Cosecant, unlike my mistake the last time, is the reciprocal of sine, so 1 over y. What's the reciprocal of negative 1? Negative 1. 2 pi over 3. So this is where it's going to take you some time to remember that pi over 3 is the same thing as 60 degrees. So 1/2 root 3 over 2. 2 pi over 3 ends up being in quadrant 2, so that's going to be negative 1/2 and root 3 over 2. So if you have cotangent's y over x, so we're doing negative 1/2 over root 3 over 2, which ends up being negative 1 over root 3, or negative root 3 over 3. This is almost the same thing as asking what is cotangent of 60, which is the same thing as tangent of 30, which is always going to be root 3 over 3, but just make sure you have a negative sign. 210 degrees, well, go to your unit circle, find 210, and you end up getting the point negative 3/2 and negative 1/2. Or remember that it's a 30-degree reference angle in quadrant 3, so that's that. Cosine is the x coordinate, so negative root 3 over 2 is your answer. 270 degrees, if you go to your unit circle, is the point 0, negative 1. Sine is asking what's the y coordinate, so negative 1. Tangent of 60, if this is one of your memorized values that you already have, root 3, done. That's it. That's literally all you have to do for any of these problems. But if you're trying to solve your way through it, it's 1/2 and root 3 over 2. Tangent's y over x, so if you have root 3 over 2 divided by 1/2, the 2's cancel off and you're left with root 3. 5 pi over 3 is a 60-degree reference angle, or pi over 3, so you would have the point 1/2 root 3 over 2. 5 pi over 3, let's see, that's 1 pi over 3, 2 pi over 3, 3 pi over, no, not 3 pi over, 4 pi over 3, 5 pi over 3. Oh, that's in quadrant 4. So positive x, negative y. Sine is asking what is the y coordinate at that point, so negative root 3 over 2. Done. 150, you can go straight to your unit circle, find 150 degrees. What's the x coordinate? Done. Negative root 3 over 2. That's it. 7 pi over 6, same thing. You can go to your unit circle, find 7 pi over 6. It's asking for sine of that angle, so what is the y value at that point? Negative 1/2. And again, that's all the work you have. Now, you do have an answer key for your worksheets. If you just write down those answers and not understand this, it's not going to be very helpful to you. So make sure you're practicing that process in your head. All right, so what about the problem like this that we did before? Well, let's look at the points. Go to 120 on your unit circle. What's your ordered pair? Go to 330 degrees. What's your ordered pair there? And so cosine is x, sine is y. So cosine at 120 degrees is negative 1/2. Cosine at 330 degrees is root 3 over 2. Sine of 120 degrees is root 3 over 2. Sine at 330 degrees is negative 1/2. So if you multiply these out, you end up getting negative root 3 over 4 minus negative root 3 over 4, which becomes plus, so you end up getting 0. Tangent of 2 pi over 3, so this is something that you want to commit to memory. This is something that you could probably do as tangent of pi over 3 is the same thing as just root 3. Tangent of pi over 3 is just root 3. However, tangent of pi over 6 is root 3 over 3. And if you want to put the cotangents, again, the cotangents have to be the opposite angles. So these are your tangent and cotangent, remembering stuff from, but in radians. So something that's tangent of 2 pi over 3 is going to just be root 3. But 2 pi over 3 is in quadrants 2, negative x, positive y, so that's going to be negative root 3. Tangent of 7 pi over 6, well, that's just always going to be root 3 over 3. 7 pi over 6 is in quadrant 3, so that means that negative x, negative y, if you divide them, it's positive. If you multiply these out, you end up getting negative root 9, which is negative 3 over 3, or negative 1. So, again, a lot of PreCal is a lot of memorization and problem solving your way through it. So make sure you're practicing, make sure that you're problem solving your way through this so that you understand what you're doing. If you have any questions, let me know.